So as I told that our final target is a DFA, right?
Yes, sir.
Not a DFA, minimized DFA. Now the purpose why exactly you are saying that it is a minimized DFA and what exactly this gives us an output. This minimized DFA will act as a lexical analyzer, or in fact we can say that if we would like to construct a lexical analyzer or we would like to design a lexical analyzer, we would like to construct this minimized DFA. Now if we can successfully construct this minimized DFA, then we can accept the strings and we can identify the tokens. The moment you are accepting a string, the string acceptance will be in the final state, and this final state will give me the output in the form of a token. So how exactly in the form of a token, we will look into that, but ultimately our target is to go for a minimized DFA. So for that particular purpose, we would like to have the cycle of implementations from a regular expression to a non-deterministic finite automata, and then from a non-deterministic finite automata to a deterministic finite automata, and from a deterministic finite automata to a minimized version of the DFA. Now, the moment we have constructed this minimized version of the DFA, we will ensure that, or we will declare that we have constructed the lexical analyzer. Right? That's how the importance of the NFA and DFA is being presented in this particular journey of designing a lexical analyzer.
Sir, it means that minimized DFA is a lexical analyzer.
Yes, it means that the minimized DFA is a lexical analyzer. Okay.
Okay, sir.
So how exactly it will be a lexical analyzer, we will talk about that more in subsequent classes, but currently we will understand this particular process through various algorithms, right? I hope all of you had done manual discussions previously. Here, regular expression to the NFA, then NFA to DFA, and then from DFA to minimized DFA. There are some manual interventions or manual practices, as well as some few discussions on algorithmics process. But we will now, what exactly we will do is, we will do this manual process and map it to the algorithmic process. There is no change in the manual process, but we will map this manual process to put it in the algorithmic process, right? So that our implementation process could be understood better and we can easily construct a deterministic finite automata. So in the first target, as you can see, first of all, we would like to go for a regular expression to a non-deterministic finite automata. So I hope all of you remember that. And can anyone highlight the existing process which you have been discussed in your finite automata concepts in the previous semester? Yes. How exactly you construct a non-deterministic finite automata from a regular expression? Yeah. If you're not able to remember, nothing to be worried. I'll just go across, but I just wanted to have just a knowledge from your side that how much you have understood and how much you have remembered. I hope all of you must have been followed with the rules of regular expressions. Rule number 1, epsilon is a regular expression. Rule number 2, phi is a regular expression. Rule number 3, a is a regular expression. Then rule number 4, we have implemented OR operation, AND operation, or concatenation operation, and then clean closure operation, right? So based on these operations, you must have constructed the non-deterministic finite automata by introducing new states. Okay. So the same process here also we are going to follow. which is called as in Thomson's construction algorithm. Thomson's construction algorithm. So here there is no computation involved. It is all about construction. There is no computation. Reminding on that, there is no computations. We are simply going to construct, right? The moment you're, why exactly you're saying construct? Construction says what, or what, on what basis the construction happens? Can anyone give me some example? In any sense. Maybe constructing a building or constructing a table or constructing a chair or anything, any example can be taken up.
Sir, can you please repeat the question?
Why, what exactly you mean by a construction?
To build a structure.
Build a structure. So how do you build a structure? In a structure, there might be multiple
In a
components.
manner.
So first we plan the structure, how it is.
Okay. So whatever structure you are going to construct, definitely you are having a plan how to construct it. That's what the regular expression here, the regular expression rules are there to help you out in the construction process. But how do you construct? The construction happens from, say, you are constructing a pillar, right? What are the components of a pillar? The iron bars, cement,
Gravels.
right? Then
The
sand,
gravels.
right? Pebbles. So are you combining them together at one instant of time and constructing the whole pillar at one instant of time of, let's say, 20 feet pillar? Is it possible to construct?
No.
20
No,
feet
so
pillar
one
at
by
sir.
one process.
So you are putting it one layer, then another layer and another layer. Likewise, that's what the construction process talks about. Adding up components more and more to the system to enable more capability of that particular construction process. Okay. So that's how the name construction is being presented at this particular point. Why exactly we say it is a construction. So let me go through the manual process first, as it is being discussed in the previous semester, and then I will go across with a modified version to the algorithmic process, how exactly the algorithm is going to work out. So in the manual process, what happens? In the manual process is being considered in two phases. First, basic phase, then second, operational phase. Now in the basic phase, we address the elements, basic elements like lambda, phi, and single alphabet. Any alphabet can be considered, right? And in operational phase, we do address the operators like union or, then dot or concatenation, and clean closure. These are the three basic operations or operational phase we are dealing along these three elements. Fine. So in the basic phase, let us remember that basic phase, the moment I'm talking about a lambda, we may have got something like this. Isn't it? I hope all of you can remember this. For accepting a lambda as a string, I must have got an initial state. I must have got an final state. I should introduce an age from initial state to the final state on an lambda. Okay. Now what exactly
Yes,
we have done
sir.
here? What exactly we have done here? We have introduced the initial state. We have introduced the final state. Then we have introduced an age in between the initial state, from the initial state to the final state, labeled lambda, and said that this is a NFA. Now what exactly we have done? If we are saying that this is a NFA, then I have mentioned what is Q. Q is nothing but I and F. What is sigma? Sigma is lambda. What is Q naught? Initial state is I. What is F? Is small f. And what is delta? Delta is nothing but delta of I comma lambda leads to F. So this is the finite automata or the NFA, which is going to be the output. Now what kind of structure I need to follow to represent this particular output? Or what data structure you would like to follow to represent this as an output, because definitely your programming language doesn't support any kind of a graphical construction. Any kind of graphical representation has to be represented with linear data structure. I hope all of you remember that. Any non-linear data structure has to be represented through a
Linear data structure.
right? So if this is a non-linear data structure, considering this is an NFA, then what could be the linear data structure which will be representing this NFA? I can say in C language, we can very well say that this could be a structure having components of states, then input, then I have got an array of 2-dimensional, because it is a delta is a matrix. Then I have got one initial state, so it could be one variable of type character or maybe anything, and then I could have a list of final states. So these 3 elements are lists. So list of initial states, sorry, list of states, list of input symbols or input alphabets, list of final states, array which represents your transition table, and this is an element which talks about an initial state. So if I'll represent like this, my justification to a programming construct is 100% fulfilled. Okay, now what exactly I've done? I have defined everything. I have not computed anything. I have defined anything. I have just added up the components and I have defined all these component elements, whatever is depending on my requirement. Okay. Similarly, if it is an phi, I have not presented it for phi. If it is a phi, then again I will introduce one initial state. I'll introduce one final state, but we will never introduce any edge in between the initial state and final state, which will justify the language of phi as empty string. So language of phi is equals to an empty language. There is no strings available. The language of epsilon or lambda is equals to lambda. There is a string available whose length is 0. And what about the next one, A? It again says initial state we have introduced, final state I have introduced, and an age I have introduced with the weighted value of A. Right? So what should I do or how should I write a program to perform this basic constructions on regular expressions? So I should have a function, let's say basic. We'll take how many input? What is the length of the input? The length of the input is going to be 1. So there will be only one argument. And specifically the argument could be of type either it should be a lambda or it could be a phi or it could be a single alphabet. So if this is the case, then what exactly we will do? We will say that Q is I and F. We will define it directly. There is no requirement of specifying anything or computing anything. Sigma is the whatever the element is being presented as an argument. Here, let's say it is lambda. Sigma will be assigned with the argument. So let me put it as an argument here. Right, sigma would be argument. What is delta? Delta will be a transition function, right? It will be a movement. So it will be a matrix. So matrix will contain the number of rows and the number of columns depending on the number of inputs. So there might be 2 rows, I and F, and I and F, there will be 2 rows and 1 input lambda. So the resultant is going to be here, it is F, here it is phi. Similarly, initial state Q naught is equals to I, phi F is equal to F. So this is going to be defined. Now the moment I have defining them, this represents an ANFA. Now this definition is considered as one output of this particular function basic construction. Right? I've just mentioned it roughly. to make you understand, but ideally this will be containing a structure. The structure of the elements are going to be updated because every NFA is going to be considered as one object kind of a thing. Now, if I would like to communicate in between these two, then this is going to be one NFA, NFA1. This is NFA2. Likewise, there might be another NFA, NFA3. Now, if I need to perform then NFA an OR operation, then I could have NFA1 or NFA2 or NFA3. Likewise, so this has to be in a structure, right? And every instance has to represent with their respective values. Okay, is that clear? I'm just talking about the basic.
Yes, sir.
Moving further, here this page talks about OR operation and AND operation or concatenation operation. Any changes which you can identify that the changes are being incorporated, or any substantial changes to the previous discussions? Any substantial changes to the previous discussions? Or the previous theoretical concept which is being presented for OR operation or AND operation? No? Or not able to identify? I hope this was in the previous discussion, this was something like this. Isn't it? That was the earlier in finite automata, this must have been discussed, this kind of an OR operation, right?
Yes, sir.
But now we are changing it to something like this, right? So the purpose of change I will discuss, but currently this is the change. It doesn't mean that we are not going to implement the previous one. The previous one is also going to be implemented in certain cases, case to case basis, right? It is case to case basis. Okay. Now, what exactly this OR operation is supposed to perform? It has to take two inputs, one NFA1 and NFA2, or might be more than one input, more than two inputs also. So minimum operation is going to have minimum is 2. It can have more than 2 also, but ideally this OR operation, as it is binary operation, so it will proceed further based on the associativity is concerned on the process. Just a second. So the basic objective are same, basic inputs are same. So here, the moment I'm supposed to perform an OR operation at this particular point, what are the input to this OR operation? The inputs are NFA1 and NFA2. So can I consider these two NFAs as two arguments to a function of OR operation? Okay. Now this is a function which takes the NFA1 and NFA2, and the output of this function is NFA3. Right? This NFA3 will talk about, let's say Q3, sigma 3, all components, delta 3, Q03, and F3. Where NFA1 is having component of Q1, sigma 1, delta 1, Q01, and F1. And NFA2 is having component of Q2, sigma 2, delta 2, Q02, and F2. Right? All distinct elements are being provided, these two elements. Now, what happens in this particular OR operation? Are we doing any further changes to this to existing NFS? Or we are adding up some extra factors to the existing or to the existing NFS? Yes.
नहीं समझ में आ रहा है.
Now, if at all I am having this NFA, let's say I am having one NFA as A and one other NFA as accepting B. Now I would like to perform an OR operation. How exactly I can do? What exactly I can do here? To perform an OR operation and results in an expression of A or B. So what should I do? Or what should you do as per the theory of automata is concerned? Yes. So earlier A is an individual regular expression, B is an individual regular expression. Now we are combining A and B, generating a single regular expression with an OR operation. That is union, right? So if A is a regular expression, the language of A is equals to A. The language of B is equals to B. Now, if it is A or B, then we are supposed to specify language of A union language of B generates A comma B as two strings of this regular expression. Right now, if this is the regular expression, then there must be one NFA because it has to be combined or performed of OR operations. So to generate this one NFA, we need the help of the existing regular NFA for A and the existing NFA for B. So which I have considered here, these two elements. Now I need to combine them as one NFA. So how can I combine them? To perform this OR operation. Either I will get A or I will get B. Can I do like this, the way it is being presented here? Yes or no?
Sir, we can take both of them together.
Both of them together like
drawing an arrow from the
yes.
an arrow from the final state of both the NFAs and then meeting them at one conjunction point.
Like this?
Yes, sir.
Okay. Now what it will be? This will be the new final state. That's what
New final
probably you are trying to tell. So this won't be any further final state. This will be final state. So what will the value of this edges? The value of the edges are going to be lambda because A is already being existing here.
Yes, and A into lambda will be A and B into lambda will be.
Great. Now this is the this is all about the final state. What about the initial state? Which one is going to be the initial state?
So initial state for what?
For this NFA, every deterministic finite automata or every finite automata has to have only one initial state.
Yes, then the beginning one, which we originally had.
This one?
Oh,
or this one or this one?
Yes, this.
Now, if I will consider this as the initial state, then how can I get B?
Yes.
Right. So I hope
So
all of
they
you
have to come from one point.
You can form a new one with epsilon.
Yes, sir, they can come from one point, one location. Lambda, right. Lambda. Yes, sir.
So this is the new initial point. This is the new final point. Okay, which says that any addition of edges with lambda doesn't affect to the original length. Now tell me, have we changed to this original non-deterministic finite automata which we have constructed for A and B individually?
No, sir, not at all.
We have not changed anything. What exactly we have done? We have and edges to justify our operation. But we have not changed to the original one. So everything in NFA 1 and NFA 2 will remain in the new NFA. If I'll consider this whole element is the new NFA, right? Let me just number it for your kind reference. Let's say this is 1, this is 2 state numbers, this is 3, this is 4, this is 5, and this is 0. Now in the NFA 1, are the component of NFA 1 are what? What is Q? Let me talk about that a little bit more. NFA 1, Q is how much? 1, 2, the state values. What is sigma?
Yes.
What is sigma?
A.
A. I'm talking about this one only, NFA 1.
Yes, sir.
A. What is delta? Delta of 1,
Delta.
1, A is equals to 2.
Sir, both.
Right? What is Q naught?
1.
1. What is F?
2.
2. 2. Again, it is Q. That is 3.
3, 4.
Sigma is
B.
B. Delta is
4.
3, B equals to 4. Then Q naught is 3. F is 4.
4.
Now this is the existing two elements with which we have not done any change. Now we have added few elements. So what are the elements we have added? We have added 0. Sorry. We have added 0. We have added 5.
5.
As states. Right? Now what will be the new set of states belongs to this whole newly generated NFA? So this is
0.
N3. So N3, what will be the value of Q? Let me put it something different. Q1, sigma 1, all these ones. Here it is 2. And let's say this is 3. Now Q3 is what? Q3 contains what? 0,
0, 1, 2, 3, 4,
3, 4,
and 5.
Now can I write Q3 is equals to Q1 union Q2 union 0, 5?
Yes, sir.
Yes?
Yes, sir.
Okay, great. Now, what exactly we have added further? We have added
Lambdas.
states. We have listed the states. Now we have added the edges. One on what value? Lambda. Now what is sigma 3? Sigma 1. Sigma 1 union sigma 2 union
lambda.
Right?
Yes, sir.
What is the initial state, new initial state? Q naught 3.
0.
0. What is the final state?
5.
5. We are defining it directly. We are not computing it. We are just introduced and we have defined them as this. Then what is delta? 3. Delta 3 is going to be a table of 6 rows because there are 6 states, 0, 1, 2, 3, 4, 5. And the inputs are going to be A, B, lambda. But will there be any changes to this transition?
No, sir.
So the same transition will happen here. 1 on A is 2, 3 on B is 4. Rest elements, whichever we have added here, will be reflected. 0 on lambda is 1, 3. right? On 1, there is only one transition. On 2, there is a lambda. It moves to
One transition.
5, one transition. On 3, only one transition B, which is already being defined. On 4, there is another transition added, that is 5.
Only lambda.
Right? So only lambda. On 5, there is no outgoing transitions. So what exactly we have done? Delta 3, which we have computed, is nothing but delta 1 union delta 2 union some specific transitions we have added. What we have added? We have added delta of 0 on lambda union delta of 2 on lambda union delta of 4 on lambda. Isn't it?
Yes, sir.
Right. So now we have constructed, we are supposed to give them a structural representation. Okay. So what exactly I was talking about? My NFA is already existing, NFA1, NFA2, or operation. So this takes two, let me put it once again. So what exactly I'm talking about? I'm talking about an OR operation. NFA1 as an argument 1, NFA2 as an argument 2, which transfers all the components of NFA1 and NFA2 to the new process. And now NFA3 is going to be constructed with Q3, sigma 3, delta 3,
Delta
Q0
3, Q0.
and F.
Yes.
Now we can define all those elements here, right? Because NFA1 is already being available as an argument, so you can always write Q1 union Q2 union 0, 1, 5. So it depends on the type of NFA you are supposed to construct or what kind of states you are supposed to introduce as an initial state and a final state. But ideally, as per this particular diagram is concerned, we are not introducing any final state. So this will be on case-to-case basis. I will discuss on that particular matter. I hope it is clear. What exactly I'm just putting you in an algorithmic view. What exactly you're supposed to write in the algorithm.
Sir,
We
please,
are not computing
once again.
anything. Yes, tell me.
Sir, what you just said, sir, I was having a net issue.
I'm just saying that whatever we are discussing, I'm just trying to provide you an algorithmic view that what your algorithm should behave, how exactly your algorithm should behave. Because there is no computations. Because there is no computations. We are simply introducing new components and manipulating with the existing sets, existing set of states, or existing set of input symbols, or existing set of transition functions. Right, we are only manipulating on all those components, simple, nothing else. Okay.
Yes, sir.
Now the similar thing will happen for AND operation also. So I can put it as an AND. And again, there are two arguments, NFA1 and NFA2. And then I can put it, construct NFA3. So every output of this particular functions is one new non-deterministic finite automata. They will be having their new states representation, and the input might be same, but states are definitely is going to be new, and they are distinct from each other. Now, why exactly I'm saying distinct from each other? Now, for example, I'm trying to construct an NFA for A, B, and A. Now, the NFA for this A is different. The NFA for this A is different because they are dependent on the position where they are supposed to appear for. Okay. Similarly, if we talk about an OR operation, then sorry, the clean closure, then it will be having only one operand, that is only one NFA1, because this is an unary operation, and accordingly you can add on. So what are the add-ons? Existing NFA is there, NFA1. The add-on states are these two add-on states, introducing new initial and new final, and these are the 4 edges which are getting added up, 1, 3, and 4, along with the existing edge, right? So that's what is all about. How do we going? How exactly we are going to represent this construction, manual construction process through an algorithmic view, right? Now, at this particular point, I would like to give you a task. This is one of the examples which I just explained manually. Just observe, we are saying that R equals to A or B whole star, then A, B, B. Now, as per the operations are concerned, star operation has to be performed first. So star is applied on A or B. So now A or B, before A or B, I have to find for A and I have to find for B. So first A is being found, then B is being found, then A or B is being found. Now on this A or B, we are finding out AB whole star. Then post that, again we are having the next character is A. So combining them together, 7 to 8, concatenation operation. Here for concatenation, we are not adding up any further states in between to reduce the complexity, but you can as per the previous elements are concerned. So this part of the string is A or B whole star. This part of the string is ABB. Just showing you an explanation on this particular process, the construction. So to summarize the discussion, what we had, what exactly I've summarized, how many functions? One is basic construction. Basic construction will take either lambda or phi or single alphabet as an input and construct the output of this is going to be always a 2-state NFA, right? The output of this is going to be 2-state NFA. Then we are having an OR function having N1 and N2 as component. The output is N3.
N3.
Right? Similarly, for AND, N1, N2, and for clean closure, N1. Now your task is, at this particular point, is to fill this content and show me in the next class. I'll verify in the class itself. Please type it down, or you can write it in your copy and take a snap. And I'll just see how much you have understood by filling it out. So I may ask randomly to any one of you, or I may go roll number wise calling.
Okay, sir.
Let's close it down.